So we're going to walk through an application. This is sourced from Professor Leonard on YouTube. It's his Calculus 1 in Section 2.4 video. And this is a formula for some DVD sales, some DVD movie of sales, where the function S of t, where S is the number of sales in millions of copies sold, and t is the time in years. And we have a couple of questions that we'd like to answer just based on the function itself. So first, we want to find the rate of change or derivative for the sales function. And that's going to allow us to solve one of these other problems, actually two, so 2 and 3. But it's essentially, again, we're just solving for an equation with respect to t, so that we could plug in any point and figure out what that rate of change is in sales. So I have written this out so that we could solve this. I've also listed the general formula for the quotient of derivatives, and we have s prime of t is how I'm going to begin, and then I'm going to write this out as the term, the entire term of the denominator multiplied by the derivative d with respect to t time of 7t. That's going to be minus 7t multiplied by the derivative d with respect to t of that entire term of t squared plus 1. And of course, that's over our denominator squared. So t squared plus 1 squared. Now that we have this set up, well, we can just worry about the numerator, and the denominator, as we've been told, will usually not be factored out. So we can just leave it as it is. If we do begin to see a pattern, or we see that the numerator is going to reduce down to something that would require that denominator be factored out, that's fine. But let's just focus on the numerator. So we'll bring down this term of t squared plus 1, and the derivative of 7t, well, that's just going to be 7 times the power of 1 times 7, and that t then is just going to end up being 1. So we have just 7. We're going to subtract 7t, and I'm making sure I add that parentheses in front, because I will need to bring that -1 through to whatever I end up with here. So let's leave that parentheses there to remind us. So 7t multiplied by the derivative with respect to t of t squared plus 1. Well, plus 1 we know is just going to be 0. So we can do t squared is going to be 2t. All of that is still over that denominator squared. Now we can carry this 7 through to each term, and we're going to end up with 7t squared plus 7. And I no longer need parentheses. I've carried this through. So that product of 7 times t squared plus 1 is now just 7t squared plus 7 minus, and here we have 7t times 2t, and that's going to give us 14t, and then I carry that negative through, and of course I end up with simply negative 14t. That is over our denominator squared. So let's further combine that. Let's combine like terms in the numerator. And before we do that, let's go ahead and bring this 7 Let's bring that positive 7 down. That's the first thing to do. Let's bring that one down. Minus, and then we can go ahead and combine, and we can combine these like terms. And I'm sorry, this is actually negative 14t squared. 7t times 2t up here gives me 14t squared. Apologize for that. So 7t squared minus 14t squared is just going to be 7t squared. That is still over our denominator squared. And that is the reduced form of the derivative. And this is going to be what we need to solve the next two problems, or we're going to work with this. So let's go ahead and bring this up. And bring that over. All right. So that is S prime of t. So the next question is, when will sales peak before dropping off? So this question, if we want to restate this, is the same as saying, when will I have a zero slope? That's essentially what it's asking. Where for this function will I have zero slope? Well, we want to use the derivative of the equation that we found, S prime of t, in order to solve that. And we have learned how to find what we are calling a horizontal tangent line. And what that means is simply that y is going to equal some constant, such that it will be a zero slope that will kiss that point where there is zero slope. So that's what we're trying to find. So let's go ahead and do that. So we are going to set this equation to 0 and multiply by the reciprocal of the denominator, which will quickly show you that you're really only concerned with the numerator. Another way to say that is when would the denominator be 0? Well, it can't, because we cannot divide by 0. But to show that mathematically, we can just show that if we multiply by the reciprocal of the denominator to both sides, so we'd have t squared plus 1 squared over 1, and then we multiply this side by the same thing, which is just t squared plus 1 squared. That you can see that this cancels, and 0 times anything is still 0. So then it's really just a very basic algebra problem. And we can add 7t squared to both sides. This is one term. So plus 7t squared. And we have 7t squared is equal to 7. Well, we're trying to reduce for or solve for t time, and we will do this by dividing 7 on both sides. We're going to end up with t squared is equal to 1. We have t squared, which means that we're going to be dealing with a square root in order to reduce this for t time. Anytime you have a square root, you want to make sure that it's positive or negative for both solutions that are available. And we would end up with t is equal to plus or minus 1. Now, in business, of course, we're not dealing in -1 years, what happened 1 year prior to the release of this DVD in sales. What we're working with then is just the positive value 1. So the answer to this is that when will sales peak before dropping off? We can say that it will peak when t is equal to 1 or at 1 year from release. And finally, we're going to take a look at something interesting that we can do that algebra normally doesn't allow. We want to know how fast are DVD sales increasing at the time of release. When I first read this, I thought maybe that was the first day. And so I thought, okay, well, we're dealing with 1/365th of a year, and got into all kinds of complications. It's really quite simple. They want to know even sooner than the first day. They want to know when, basically when t is 0. So when our time is 0, so at 0, how fast, according to our equation that we found, are these sales increasing? So to do that, we simply take our s prime of t equation, and we will just simply say that s at 0, and plug that in. S at 0 is going to be equal to, and we'll just say 7 minus 7, 0 squared, over 0 squared plus 1 squared. Well, this is fairly simple to figure out, as we're going to reduce this down to simply 7 over, and 1 squared is 1, right? So we end up with 7 as our slope. Well, in the context of this problem, what we're dealing with and what we found is s. To bring this down, we'd say s is 7 million DVDs are being sold at the time of release. So that's our slope, and that is the solution. So at t equals 0, we have 7 million DVDs that are being sold. Let's take a look at this from Desmos and see what this looks like. So we have the function here, the original function, and we see that it's only positive values that we're concerned with. And at the time of release, we have a slope at time of release of 7 million copies. And then we said that after 1 year is where we have 0 slope. So it's exponentially increasing. It's then reaching 1 year, and then as you can see, it's steadily dropping off from there. So hopefully this video helps, and thanks for watching.